Today we're going to look at Lesson 5 from Unit 7, which is going to cover perimeter. Hopefully that's something you're fairly comfortable with at this point. What is perimeter? Just as a quick reminder, perimeter is the distance or length that it takes to travel around a figure. You can find it by adding all of the side lengths together. So I've given you an irregular polygon to work with. To find the perimeter, you're simply going to add all of the sides. Select any starting vertex that you want. I picked the one at the top left, and just go around the figure, making sure you stay in order. That way you won't skip any or miss any sides. So starting at the top left and going clockwise, I would have 9 meters, 5 meters, 7 meters, and 11 meters. We're just adding all of those together and we get 32 meters. Remember, perimeter is a distance, so therefore it should be labeled with some type of unit of measure. If you're not given a unit of measure, then you simply say units. There are a couple of quadrilaterals that, because of things that happen to be true about them, they have formulas to find their perimeter. You don't have to use the formula at all, but you can if you want it to help you save some time. So one of them is a rectangle, in which case you take 2 times the length plus the width, since there's 2 of each of them. Oh, and then the square is 4 times the length of the sides, since all of them are the same. So here in this rectangle, you could easily start up here and just do 5 plus 3 plus 5 plus 3, or because of the fact that they are each doubled or used twice, we can just add the 5 centimeters and 3 centimeters together and then double that. So 5 plus 3 is 8, and then doubled we would get 16 centimeters. And the square down here, we have 25 along each of the 4 sides, so we can just do 25 times 4, which is 100 feet. So I've given you another irregular polygon. So you would just want to take any starting point you want. I used the top left and went clockwise, which is what I typically do. So 6.5, 6.2, 4, 7.8, and 4.3. We're just going to add those up. We get 28.8 millimeters. Sometimes you will need to calculate some unknown piece of information. So you'll see here we have what's actually called a compound shape. So we have a rectangle here and then another rectangle here, but there's no measure written here along the bottom or along this small portion of the right side. So you might have to calculate those. So the bottom length here, we know the distance from this side to here is going to be 6, because we can see that right up here at the top. From the left side to that right side of the part that shoots up, we're looking at 6 millimeters. And then this portion right here, from this offshoot to the right side, is 14. So if we add together the 6 and the 14, we get 20 millimeters for this bottom portion. And then this small right side, we don't know what this length is, but we do know the entire height is 15 millimeters, and we know that this little part that goes up is 9 millimeters, so we can do 15 minus this 9, and then find out that this part right here is 6 millimeters. So again, start somewhere. I like to start at the top right and go clockwise. So 6, 9, 14, 6, 20, and 15. Add all those up, and we get 70 millimeters as our perimeter. Some of the calculations will not be quite that easy. Sometimes you're going to be looking at things on a coordinate plane and need to give the distances. So the horizontal and vertical distances on the coordinate plane, you can simply count the boxes. So here, this one in purple, that's this side, and I just counted. You start at one point and you just count every box that occurs. So I don't start at 1, I start at 0 at my point, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 boxes. So I marked that as 10. And then the horizontal length here, again, you don't start at 1, you start at 0. Count every box that occurs. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So we have 12 for this length down here that I highlighted in red. However, we cannot count a diagonal distance. We're going to have to calculate that. So when we have horizontals and verticals, they make right angles. So we have a right triangle, which means we can use the Pythagorean theorem to find out the length of the hypotenuse. So we will do a squared plus b squared equals c squared. So 10 and 12 are our legs, so 10 squared plus 12 squared. 10 squared is 100, 12 squared is 144. We're going to add those and get 244. Now remember, that is equal to the c squared, not to c itself. So we will need to take the square root to get rid of the squared, since square roots and squares undo one another. So if I take the square root here, I have to take the square root here as well. So the square root of 244 is 15.6. So the length over here of this hypotenuse is 15.6. Start wherever you want, add them up. This time I started down here, went 12, 10, and 15.6, and we got 37.6, and since we weren't told a unit, we just say units. Here we have another shape. This one's a quadrilateral, so we count our horizontal and vertical distances. So from D to E, that's 4 boxes. From E to G is 4 boxes. And from G to F is 6 boxes. But this is the measure we don't know from E to F. It's a diagonal. Now, this shape right here is not a right triangle, but I can go directly down in a vertical manner, straight down from E to side GF. And this would be a height of 4, and then to get over to F, that would be 2. So the legs are going to be 4 and 2. We're just going to use this right triangle right here from E straight down. There's no name right there, but underneath the 5. And then over to F. So 4 squared and 2 squared will be our legs. So 4 squared is 16, 2 squared is 4, 16 and 4 add together to make 20. Remember, that's the value of c squared, not of c itself. So we need to take the square root to get rid of the squared. The square root of 20 is approximately 4.5. I had to round that up, I think, as the approximate value for c. So you take your shape, and I started at the top left again and went clockwise. So 4, 4.5, 6, and 4, and that adds up to 18.5 units. A couple of things to remember or keep in mind as you work through your perimeter questions. Be sure to add all of the sides, so develop a system and always go in a certain direction around the figure or something like that. Like for me, most of the time, top left, go clockwise. That's just my system, but yours might be something different. Make sure to count or calculate all side lengths and write them down so you don't forget what you calculated them to be. And to make sure you label your answer with a unit of